sketching the graph of the function using its derivatives. This is the two things we're going to try to accomplish in today's lesson, which is to show you how to sketch the graph of f and also to look at all the properties of the first and the second derivative. This is a good summary for you to review the information of what the first derivative can give us and also the second derivative. Remember that critical points are the x values where the first derivative equals to 0 or is undefined. And we know that a function is increasing if the first derivative is positive and decreasing if the first derivative is negative. And in addition to that, we can also say that if the first derivative function is increasing, then the graph is also concaving up, because where the first derivative is increasing, that's where the second derivative is positive, and vice versa. The local max and the local min can also be found by using the first derivative test or the second derivative test. So if f prime changes sign from positive to negative at the critical point, then that's a local max. And if it changes sign from negative to positive at the critical point, then that function value is a local min. That's part of the first derivative test, which gives us the max or the min. The second derivative of the function tells us about the concavity of the graph, whether it's concaving up or concaving down. And we know that if the second derivative changes sign where at the location where it equals to 0, then that is an inflection point. Okay, now this is the second derivative test, which is another test that we can use to help us find the maximum and the minimum value. From time to time, this test would be easier to use than the first derivative test, but now you have two tests and you can use whichever test you want. Say if you want to use the second test, the second derivative test, then you don't have to make that sine graph, that sine chart for f prime. If you use the first derivative test, then make sure you make a sine chart for f prime. But the second derivative test says this: if the second derivative evaluated at the critical point is positive, then that's a local min. On the contrary, if you evaluate the second derivative at that critical point and it happens to be a negative number, then that is a local max. Okay? Now, the shape of the graph can be described by its derivative and also in words. For example, if you look at a curve that looks like this, then we say that this part of the graph, if the graph looks like this, then we say that the part of the graph is increasing. This part is increasing. Okay, and we know that the first derivative is positive if the graph looks like this. That means the graph is increasing and is positive. But we say that it's increasing if we want to discuss about its concavity, then we say that it's actually concaving down. Okay, so concave down. If I were to study its second derivative, then I know for sure that its second derivative is going to be negative. So if it looks something like this, it's increasing, concaving down. And if it looks something like that, then that means that it is decreasing, concaving down. So this is decreasing, right? and it's concave down. And the second derivative is going to be negative. Okay, good. If your graph looks like this, then we say that this part is decreasing but then concaving up. Okay, so it's decreasing. Okay. This is related to decreasing, concave up. If we find the second derivative on that part, it will be positive. And then over here, this is, the graph is increasing, so increasing, concave up. And if we study its second derivative, it's also going to be positive. So make sure you know how to distinguish between each part of the graph and know how to describe them. It's important when we're trying to sketch the graph of f using its derivative. Okay, so make sure you review these so that you remember them. All right, so I'm creating 3 simple steps for you to follow when you sketch the graph of the function using its first and second derivative. First thing you do is you create a sign chart for f prime, create a sign chart for f double prime, and then use the properties from page 1, which are these, but mainly that. Okay? All right. So first step, create a sign chart for f prime when we want to sketch the graph. To create a sign chart for f prime, we need to find its first derivative. So I'm going to do it over here. So f prime equals to x squared minus x minus 2. That's f prime. In order to create the sign chart, I need to find its critical point by identifying where it equals to 0. And so the critical points are x equals 2. If you solve each one of these binomials, you're going to see that x equals to -1 and x equals to 2. I also will need to create a sign chart for f double prime, so might as well find the second derivative now. So f double prime is taking the derivative of this function, 2x minus 1. Okay? And setting that equals to 0 implies that a possible inflection point is going to be x equals to 1/2. If you solve this, you're going to get x equals to 1/2. So I will now create a sign chart for f prime and f double prime. Try to make it as long as you can. So let's call this one that. Okay. Let's call this one over here like this. All right. Now the first one is for f prime. The second one is for f double prime. Okay, sorry, f prime, f double prime. There are arrows on these sign graph. Okay. We're gonna go ahead and plot -1 and 2. So here's the middle. Here's 0. Let's make this -1, 1, and 2. And the critical points are -1 and 2. So these are where the first derivative equals to 0. And so we need to now go ahead and look for, we do a sign graph. So pick a number to the left of -1 and plug it in here. to see what the derivative is, and if you do that, you're gonna find out that the derivative are positive, anything to the left of -1. And then if you pick a number in between, pick 0. If you plug 0 in there, you're gonna get negative. Okay. And if you pick a number to the right of 2 and plug it in there, you're gonna get positive, like that. So I just made a sine graph for f prime. I'm also gonna make a sine graph for f double prime. So notice that x equals to 1/2, so 1/2 would be like halfway. So here's 1/2. So this is 1/2, right? 1/2. X equals to 1/2, and I'm gonna transfer these points down here as well because those are kind of like my critical points. So transfer those down here, and like that. So this would be like -1 and 2. But remember that the second derivative is 0 there, and if I pick a test point to the left of 1/2 and plug it into the second derivative function, expect to get a negative number. So it's negative here, like that. And then if I pick a number to the right of 1/2 and plug it in, I'm going to get a positive number. And there's positive. Now I kind of put these two graphs together and I make a conclusion. So what I'm going to do is I'm gonna draw a, if you don't mind, I'm going to draw a third number line down here, and this third number line is going to summarize the first two number lines. Okay, so it's -1, and then you have another number there, and then you have another number here. Okay, so remember that here's -1, here is 1/2, here's 2. When we look in this region, we can tell that the graph is increasing, concaving down. Okay, so make a little note for yourself: increasing, 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 concave down. Okay. In between -1 and 1/2, the graph is decreasing, concaving down. Okay, decreasing, concave down. That's in between -1 to 1/2. Decreasing, concave down. From -1/2 to 2, it is decreasing, concave up. So decreasing, concave up. Okay. And then after 2, it is increasing, concave up. Increasing, concave up. All right. And this is where the graph turns. This is where it's going to make a turn. This is where it's going to make a turn. Okay. So turn, turn, and then this is actually inflection. Inflection. Okay. Let me turn on the light. For some reason, it just turned off itself. Okay. So now we're going to sketch. So remember, increasing, concave down. So increasing, concave down is going to turn here, right? So it's increasing, concave down. So it's going to look like this. Okay. Increasing, concave down. It's going to turn like that. Okay. And then it's going to decrease, decreasing, concave down, decreasing, concave down. And then there will be like an inflection there. Decreasing, concave down, and then there's going to be inflection there. So we're going to go ahead and kind of go decreasing, concave down, right? So we decreasing concave down. Oh, sorry, decreasing concave down with an inflection right here. Inflection, okay, and then decreasing but concave up. Decreasing but concave up. And then we turn here at 2, and then it increases concave up. Increases concave up, okay? Again, we begin by sketching increasing concave down. So increasing concave down, and then you decrease concave down, and then until inflection is kind of like in the middle, and then you continue to decrease concave up, decrease concave up until you turn at 2, and then you increase and you concave up. And that's how you sketch the graph of that using its derivative. I thought that was pretty cool. All right, try problem number 2 yourself. Okay, I'm gonna kind of I'll give you the sine chart, and I'll see if you can put it together. And if you need help, then see me tomorrow or the next day during tutorial. So to sketch this graph, we once again have to set up the 2 number lines. So the first derivative function is going to be 12x to the third minus 24x squared plus 12x, and setting that equals to 0, factor out a 12x, we have x squared minus 2x plus 1 left inside. Okay, so our critical points are going to be x equals to 0, so x equals to 0 and 1. Finding the second derivative means we take the derivative of the first derivative minus 48x plus 12, factor out a 30, factor out a 12. We have 3x squared minus 4x plus 1 left inside. We can throw the 12 away because if we divide both sides by 12, it disappears. And factoring this trinomial will give us 3x minus 1, x minus 1. So our possible inflection points are going to be 1/3 and 1. So now we go back and we create the sine graph. So I'm going to sketch a sine graph for f prime, and I'm also going to sketch a sine graph for f double prime. Call this sine graph f prime, call this sine graph f double prime. Label 0 here, should be in the middle. And then label,
you want me to step outside?
Label 1 here. And then we're going to go ahead and also label the second derivative 1 here, and then it's 1/3, so it's going to be somewhere over here. That's 1/3. Okay. Now go back to the first derivative and put zeros there. And now we're going to go ahead and finish this sine chart. When you pick a number to the left of negative and plug it in there, it is going to be a negative sign. When you pick a number to the right of 1 and plug it in there, it's going to be a positive sign. When you pick a number between 0 and 1, you really have to test. So I'm going to pick 0.5 and I'm going to plug it in there and see what the first derivative gives me. So 12 times 0.5 raised to the third minus 24 times 0.5 squared plus 12 times 0.5, and that gives me a positive number. So the sign in here is a positive number. Okay, great. Now let's do the same thing for the second derivative function. When you pick a test point to the left of 1/3, say 0, and plug it in there, you're going to get a positive. So these are positive. When you pick a number in here and plug it into the second derivative, you're going to get a negative number. And then when you plug a number after 1 into the second derivative, you're going to get a positive number. So now we summarize this. Bring these down, so that's 1/3. This is 0. Okay. And now we make a little note for ourselves. This is decreasing. Concave up. Okay. So decreasing, concave up. Okay. This is where the graph turns. From 0 to 3, from 0 to 1/3, the graph is increasing, concave up. Okay, so increase, concave up. From 1/3 to 1, and by the way, at 1/3, there is an inflection. From 1/3 to 1, it is increasing, concave down. Increasing, concave down. At 1, there is a turn, and then increasing, concave up. Increasing, concave up. Okay, so try to sketch it. Sketch the graph, and then I'll finish it for you in class, or come to tutorial and we'll finish the sketch together. We will now analyze the graph of f prime to find the properties regarding to the graph of f. So from the previous page, if you need to, you can always review this page. We know that the critical points are where the graph of f prime equals to 0. So they are here and there. So at 3 and 5. Those are our critical points. Now, if you like, you can also create a sine chart for your f prime, and it makes it easier instead of looking at the graph of f prime. What you can do is you can create a number line down here, call it f prime, and then identify the critical points, which are 3 and 5, and put zeros on there. Since the graph is above the x-axis, that implies that it is positive. Between 3 and 5, it is below the x-axis. That implies that the derivative is negative. And then to the right of 5, it is above the x-axis, and that implies that it is positive. And that helps if you don't want to look at the graph. So we can now easily identify on which interval the graph is increasing or decreasing, and I'm going to assume that there are arrows on these graphs. So it is increasing where the derivative is positive. That would be from negative infinity up to 3, and from 5 to infinity. Okay? It is decreasing where the first derivative is negative, so that would be from 3 to 5. Find the x values of the local max or local min. So we can use the first derivative tests. This will help us identify the local max and local min. So we say that local max is at x equals to 3 because f prime changes from positive to negative at 3, and local min is going to take place at x equals to 5 because f prime changes from negative to positive at 5. Find the interval of concavity. So to find concavity, we need to study the second derivative. Keep in mind that the second derivative is the derivative of the first derivative. So what I'm going to do is I'm going to informally put the symbols for the slope of this graph. Notice that since the graph is decreasing, since f prime is decreasing, the slope of f prime is negative here, it is 0 here, and then it is positive here. Now keep in mind that this is the graph of f prime. So the slope of f prime is really f double prime. So go down here and create a second sine graph, call it f double prime. At 4 is where the second derivative equals to 0, but clearly to the left of 4 is where the second derivative is negative. You made those sign, and that's how you find them. And also to the left of 4 is where the second derivative is positive, because the second derivative is the slope of the first derivative. Now this is going to help us answer the concavity question. So it is concaving down from infinity up to 4. It's concaving up from 4 to infinity, because concaving up relates to positive second derivative. Finding the point of inflection. Inflection points, it's at x equals to 4 because f double prime changes sign. Awesome. Here's another graph, which stands for the graph of the first derivative, and we're going to try again to answer these questions again. So to make it easy on yourself, sketch the sine graph for f prime. Again, since this is the graph of f prime, we know that the critical points are where f prime crosses the x-axis. So -2 would be a critical point because that's where f prime equals to 0. In addition to 1 is also a critical point because that's where f prime equals to 0. We study the value of f prime to the left of -2, and since f prime is below the x-axis, its values are negative. between -2 and 1, f prime is also below the x-axis, so its values are negative. After 1, its values are positive. Now we can answer these questions. So you have two options. You can create this, or you can just look at this and answer the question. That's up to you. The critical points are going to be at -2 and 1. F is going to increase where the derivative is positive, so it's going to increase from 1 to infinity. And it's going to decrease from -infinity to -2, and from -2 to 1. Find the x value of local min and local max. Since we have the sine chart for f prime, we will use the first derivative test. So the first derivative test says that there will be a local max at x equals to 1. Oh, I'm sorry. There isn't any local max because the sign never changed from positive to negative. So there isn't any local max. And however, there is a local min at x equals to 1. And -2 is neither, because the sign didn't change. Okay. Find the interval of concavity. So we create a sine chart for f double prime, and to do that we study the slope of the first derivative. So it's positive here, 0 there, negative there, 0 there, and then positive there. Okay, so we go to -2, we go to 0. These are where the second derivative equals to 0. And using those marks, this is the sine chart for the second derivative. Now we can discuss about the interval of concavity. So concave up from -infinity to -2, and then from 0 to infinity. And the inflection point is going to be at x equals to -2 and 0. And we'll do the last one. We'll do this problem in class the next time I'll see you.